Okay, everybody. So welcome again to PLDI. We're so excited everyone's here. It's my job to introduce our illustrious first keynote to kick things off, which, if you could come back on stage, is Sukyoung. As a brief introduction, Sukyoung runs computing at KAIST, so he's big boss there, in charge of a lot of stuff. Has done incredible research across many of the most important languages that we, as a computing field, depend on, working on ways to bring rigor and precision to the way we think about and work in those languages. And I think that the talk's going to be really exciting. It's sort of a bigger perspective of, not just pushing the frontier so you can get another paper, but how is the research that we do actually make the world a better place? How are we alleviating suffering and helping those around us, which I'm really excited to hear more about. Also, I think one thing I wanted to highlight was Sukyoung's service. So if you go to the researcher.org profile and you start scrolling down, this, most people have like a page and a half. Sukyoung just keeps going, right? So basically every SIGPLAN, every SIGSOFT committee, organization, many satellite events at all of these, Sukyoung has always stepped up. Tons of leadership in mentorship, and it's just really an honor to have you. And so we're so excited to have you kick off PLDI. Let's all welcome Sukyoung.
Thank you for the nice introduction. It really feels good to be on this stage. So, hi, I'm Sukyoung, and it is my great honor to give a keynote talk at PLDI. And the title of my talk is Programming Language Research for Technical and Social Good. This is the official educational motto of Korea, read 홍익인간, which means to broadly benefit the human world. So as a little kid, I was brainwashed with this motto. And I had a dream, like when I become an adult, I'd like to help people. I'd like to broadly benefit the human world with my own work and my own skills. And it has been long-term pondering for me. How can I help people with PL, right? As a PL researcher, as an educator, as an adult, how can I help people? So that was my long-term endeavor, and today I'd like to share my endeavors until now. So while preparing this talk, I met this article last week. The author asked, what is the fundamental purpose of higher education? And he believed that the purpose was best expressed in the American Association of University Professors' influential 1940 statement on academic freedom, which is, institutions of higher education are conducted for the common good. And it was very nice to see that we are on the same page. Oops. So today, I will talk about what PL can do for technical good and then for social good. So as you can guess, the second part is going to be brief, but let's see. And inspired by our motto, to broadly benefit PL users, that is developers, our team has been working on bringing our PL research into the real world by using our own technology, which is mechanized language specification. So our group has been working on mechanizing language specifications. We've been developing lots of tools by using mechanized language specifications, and our tools and our technologies are successfully adopted by two real-world programming languages, JavaScript and WebAssembly. So WebAssembly, in short, WASM. So I will share our experience with that with you. So what is a mechanized specification? Mechanized language specification is a language specification that defines the syntax and semantics of a language, but as executable data that programs can manipulate. Because the spec is executable, we can type check it, we can test it, analyze it, and verify it just like other programs. Because it's just a program, right? We can apply any existing PL techniques, but at the same time, because it's a specification, it has very specific characteristics that we can take advantage of to find new interesting problems. There are new technical challenges which provide opportunities for novel solutions. And this mechanized language specification is the single source of truth. I may use this term, single source of truth, multiple times during my keynote. What that means is that it is the only one description of the semantics, and out of that, we can automatically generate many artifacts. And because we can generate that from the specification, they are guaranteed to have the same semantics with the specification, right? Correct by construction. And thanks to this automatic generation, it is scalable and efficient to language growth and subsequent spec changes. As you know, all those programming languages, there are so many, right? And they are growing. And in our school, I teach the programming languages course every semester. Even though I'm the head of the School of Computing, I'm still teaching the course. And one of the homework is to listen to KAIST's 1998 UPSLA keynote. The title is Growing a Language. So that's the main core of programming language design, I think. But anyway, so that's mechanized language specification. As I said, we can generate lots of tools out of this mechanized language specifications, like parsers, interpreters, compilers, analyzers, fuzzers, you name it. And among those tools, our group is particularly interested in lightweight formal methods, especially tests. So by using this mechanized language specification, we can efficiently generate diverse and interesting tests. It's efficient because we just write the semantics once in one format and the others are automatically generated. It is diverse because that's a data. We can look at that. We know how to look at data, right? How to analyze programs. So we can see, we can explore the possibilities that we couldn't see before when the specs was written in prose in a book, right? And it is interesting to see that now that we can go further than before, we are encountering new issues, real-world problems that we've never experienced. So I will tell you our experience. And before that, recently, I've been hearing about the emphasis on lightweight formal methods, especially property-based testing, over and over again. Benjamin Pierce, who wrote this Types and Programming Languages textbook, he is emphasizing the importance of testing these days. He even said that before you prove your theorems, you'd better want to test them, right? And so with this figure, he claims that this property-based testing, it requires small amount of effort, just the same order of magnitude effort with unit testing, but with high quality by using the similar specifications with formal verification. So he's now using property-based testing for rock implementation and all that. And Mike Dotz from Galway, he shared what he learned trying to do formal methods in industry in Galway. And he emphasized the cost-effective lightweight formal methods like fuzzing and property-based testing in real world. As you know, Galway is doing lots of DARPA projects, right? And he even added that many systems do not even do the top 3 cheap techniques: code review, documentation, testing, and CI/CD. If you do that, then you are good. And yesterday, one Google researcher, developer, also said that if you are doing testing, you are good. So we can do better than that. And finally, last month, another CACM article shared the systems correctness practices at AWS. Again, actually 10 years ago, there was another CACM article from Amazon about Amazon's formal methods, how they use that and all. I was so impressed by the article. 10 years later, they are sharing what they've been doing, and now more emphasis on lightweight formal methods like property-based testing. So it looks like it's trendy that lightweight formal methods are being used widely and very helpful. And our group has been working on lightweight formal methods by using the mechanized language specification. So our work on JavaScript is called ES-Meta, and WASM for SpecTag, and I will share our experience one by one. JavaScript. You know what? JavaScript has been the #1 programming language until 2023. Now Python is the #1, maybe because of machine learning, right? But #3 is TypeScript, just altogether JavaScript, right? And the top 5 languages most commonly used in repositories created within the last 12 months on GitHub, JavaScript. So even though we may not like it, JavaScript is leading the world still. And May last year, ECMA TC39 announced this. So JavaScript its official name is ECMAScript because of some political reasons. And ECMAScript is maintained by ECMA TC39. And TC39 announced that our tools on this JavaScript manipulation is now, it was officially adopted by TC39. And that's called ES Meta. Actually, that was integrated in 2022. And all the details are in our CACM article last year. So that's one adoption story. And another is WebAssembly. After adopting this JavaScript work to the JavaScript community, we contacted the WASM community. I will tell you a little bit more details in a minute, but here is the setting for what we have been doing. So WASM is a binary instruction format for a stack-based virtual machine designed as a portable compilation target for programming languages. This language is very well known to be rigorously written. Language specification is beautiful. It's going to be music to your eyes because you are PL researchers. For a language construct like the binary operator, the specification describes its syntax, and it describes its semantics rigorously in 2 ways, in prose and then in formal rules. In prose, it's very easy to follow step-by-step instruction. #1, assert this property. #2, pop the value from the stack. Pop the value from the stack. Do some calculation and push the value to the stack. It's stack-based machine, right? So very clear. You know what to do. You know how to implement this semantics. At the same time, in this gray box, we have operational semantics, informal rules, right? And the spec editor of WASM, he loves formal rules. He don't even want to read this part. So if he has an option, he'd like to have only a spec with formal rules. And the English phrases are compiled or translated from these formal rules for the developers. So anyway, so WASM was really well written. The spec is very well written. The community group is very formal. In March this year, the community group announced that SpecTech has been adopted. 2 weeks ago, the WASM community group voted to adopt SpecTech for authoring future editions of the WASM spec. In this posting, the editor explained what SpecTech is, what it helps with, and why it takes WASM to a new level of rigor and assurance that is unprecedented when it comes to language standards. Right? And you can go visit and read the discussion. And the team had a poll, adopt SpecTech as the toolchain for authoring the WASM spec. And there are 15 strongly in favor, 17 in favor, and 1 neutral. So that was adopted. And this thing shows that not only that our tool is cool that they got adopted. Not only that, but also they have a very well-defined process to make decisions. So I'm going to come back to this point later. Okay, so with these experiences, we've learned a lot. And here today, I'd like to share some lessons that we learned along the way. The first lesson is different languages have different demands. Yeah. So this picture shows that JavaScript specification, that ECMAScript specification has been released. Yeah, I know their face, right? From 2015, the spec is released every year. And the spec is more than 800 pages. So like us, JavaScript language designer, not really designers ourselves, developers of the toolchain, we need to understand that every year coming language standard. So like an analyzer developer need to understand the semantics and then build some tools. So it was like onerous work. And Jihyuk Park, who's sitting here, back then my PhD student, he came to me like, we need to change this. This is not for a human being to do. And I was like, okay, yeah, let's try that. And Jihyuk is now at Korea University. What can we do about it? So we worked on JavaScript. We read every single line of the ECMAScript language specification. We knew that by heart. And it's like, oh, right, it's written in English, but in a very regular format, right? Again, number one, let array be the result of this function call. Let something be the result of whatever, and call this function. So even though that's 800 pages, the number of English phrases is 100 or something. So, oh, that's even before the large language model era. So we were like, we can just read the sentences and compile it to our own domain-specific language. So that was Jihyuk's crazy but cool idea. And by using that observation, we came up with our own DSL called Intermediate Representation for ECMAScript, ILES. And this is our language. If you look at the language, this is not for JavaScript program, right? This is not a programming language to describe JavaScript, but it's describing the semantics of JavaScript, right? So this language is just compiled version of the English phrases in ECMAScript, and that's very high-level functional language. So we can discuss that later. So in this language, we use JavaScript values, JavaScript ASTs as values. And from this text, we can compile it to some program written in ILES. And now that abstract semantics, how to evaluate this array literal expression in JavaScript is a function in this language. So this is the main thing. And now that we have this spec and extract the syntax and semantics out of this prose specification, we can generate parser and an interpreter automatically. And because the interpreter was extracted from this spec, that's just the same, right? Their behavior is the same by construction. So by using this, we just try to compile the existing 6 versions of the JavaScript and compiled about 96% successfully. Then people ask, what about the remaining 4%? What are they? They are written in a very weird way, like regular expression chapter. Right? And the author of this regular expression chapter told us that he wrote the implementation, he wrote the regular expression implementation in C++ first, and then compiled that to English. That's why that's written weird, and we don't want to handle that. And we picked the latest version then and filled in the missing 4% manually and ran it, evaluated its correctness by using the official test suite, and 100% was passed. So wow, it was a big step for us. And in a nutshell, this ES meta, it takes a specification written in prose. That's the input. Here, that's the single source of truth. Not a computer-friendly IL or DSL. This ECMA 262, that's the name of the spec. That's the input, and it extracts parser and interpreter and runs it. That's because the way JavaScript semantics is written is really high-level functional language. It calls a lot of functions with first-class continuations. That's why we designed this language in this way. But WASM is different. Again, after delivering this ES meta to the TC39, we contacted Andreas, like, oh, hey, Andreas, someone told us that we'd better try WASM. And he was like, oh, yeah, come visit our doctoral on the foundations of WebAssembly. Okay. And the very first morning, Andreas gave this presentation. He's like, yeah, WASM 1.0 was released in 2018, 2.0, 22, and he'd like to release the spec every year. Oh, we've heard that before, right? So that afternoon, I gave a talk and explained our work. And on Thursday night, we got together and started working on spec tech. So that's the beginning. So Conrad is here, but he was taking the picture. So not in the picture. So again, WASM is really well designed. And the WASM community group is really thoughtful and careful. So in order for a language feature to be standardized into the specification, you need to provide 4 artifacts. The number 1, formal rules describing the semantics in LaTeX. Number 2, describing that in prose, in restructured markdown. Number 3, implementation of that feature in the reference interpreter in OCaml. And finally, test suite to test the implementation of the feature. Wow, yeah, very picky. So in order to have one feature to the WASM language standard, it has really good checking. And the standardization process is not requiring this yet, but they'd like to have mechanized definitions and mechanized proofs. Yeah, it's really advanced. Then, so it's really good, but it takes a lot of time. And a spec editor is kind of a bottleneck because they need to make sure that everything is going well. So in order to make this pretty rendered version of the spec editor needs to write this. The entire thing is that restructured markup. Why they are using it, I don't know, with some political reason they said. And these Greek letters are now in LaTeX, right? So that's a bit much of work to write this semantics. But in order to formalize this large and growing language, there are many challenges. The prose is written by Andreas in these formal rules and then translated from there. Right? The prose is a compiled version from the formal rules. So it's labor-intensive, tedious, and error-prone. And for political reasons, as I said, restructured text and all those not that common tooling, so there are many hackings around. And code reviews are painful and unreliable. Do you want to see the differences of LaTeX? Oh, I don't want to do that, right? So the spec differences for a single proposal is huge and not really human readable. And finally, they'd like to have this mechanized formalization, but it takes a lot of time. It's not that easy to catch up with this speed. So this is what we did. These 6 lines, right? These 6 lines is the input that's written in the spec DSL. If you write the semantics once in this, then all the others are automatically generated. And we call that spec tag. It's a domain-specific language for defining the WASM semantics and authoring the spec. Again, it is the single source of truth. You describe the semantics in DSL, and the others, mathematical rendering, prose description, tests, and interpreters are come that for free. It is easy to write, read, and see the differences, right? And review with meta-level error checking. It is not that ambitious. It is not a theorem prover, just a preprocessor. Then people ask, like, oh yeah, I've heard about similar stories. What about K? What about Sail? How about Radix, right? Yeah, there are many awesome language manipulation frameworks. This spec tag is an in-house tool for WASM specification. We are intentionally specialized to our use case. All the specs meta notation is built in, and nothing more than that, we hope. And the backends can make domain-specific assumptions. From this too general DSL, we'd like to generate LaTeX and interpreter and tests. There are assumptions. So yeah, that's kind of limitations. And we control the implementation. We do not want to depend on the tools that someone else are developing. right? But at the same time, a long-term maintenance is an open problem, and we are trying to address this issue as well. But this worked for us. So this is the overall architecture. The SpecTech DSL describes the semantics in a declarative style, just like inference rules. The DSL is just inference rules. Then we have some checking, a little bit of checking, and compile that to external language. Then it's still declarative. It's still like inference rules. So we can generate LaTeX backend really easily from there. But you know that when you write calculi paper and pencil, then we make mistakes, right? There's a function parameters and there's function call, and you need to match the numbers and all that. If you have sequences over sequences, then you need to check the numbers, right? Our tool can do those checking. So after those checking, we compile that to internal language. And the interesting thing is this animation, we translate this declarative style to algorithmic style. That's what we call by animation. Here, briefly speaking, we reduce these ambiguities. As you can see in the inference rules, we have multiple premises, and the rules don't say what to do with them, which order. And when you have x equals y, it could be equality checking or binding. And even x equals y, if it's a binding, it could be binding x or binding y, because we are ambiguous in formal rules. So this animation step resolves those problems so that now we can describe the semantics in an algorithmic way. Number one, do this. Number two, do that. That's how we can support both formal rules and prose description. And once we have it, then it's slightly easier to make prose specification and the interpreter, and now we can generate tests by leveraging this data. Okay? So using SpecTech, this long description gets to this. Very short. Not only that, we can mix handwritten description and automatically generate text. Here, there are some markup saying that splice in the automatically generated text here, so that we can incrementally replacing the specification. So in a nutshell, SpecTech is a bit different. It sounds similar, but the single source is now SpecTech DSL, which means that the WASM community group needs to make a big decision. They need to change their way of writing the spec. With ECMAScript, we didn't even think about it. We were like, okay, ECMAScript is the God. We need to follow that, and how can we help them? Right? With this WASM, the WASM community group was so friendly and helpful, and they wanted to change the thing because they were suffering with the current status, right? So that's the main difference, and we can talk about the differences later more. And the details of this work is described in our PLDI paper last year. So again, the first lesson is different languages have different demands. JavaScript, ECMAScript 262, ECMA 262 in prose is the single source. Algorithmic prose is important for JavaScript developers and testing. Our group has been working on JavaScript analysis since 2010 when I joined KAIST. And the very first thing that I learned from working with JavaScript community is developers are the king. In this, ECMAScript, as you know, there's version 3 and version 5, but there's no version 4 because the developers vetoed that. So every language is different. And with OWASM, now I'm concerned that this PDF is an old version, but let's see. Yeah, WASM. SpecTech is a single source, and it has declarative formal rules are important for formalization and proofs. For the other languages, we've been lucky to work on JavaScript and WASM. They have specifications, and their specifications were rigor. But now, the other languages may not have specifications. And when you say specification, people may think differently, right? Some people think a set of input and output pairs is a specification. So we need to talk. So There is often no specification, and algorithm formal rules or pseudocode may be preferred. And Ralph prefers pseudocode description for the Rust language specification. And so we'll see how that goes. And the second lesson is specifications are not oracles, meaning that it doesn't work well. They have bugs, right? This is a ECMAScript, and I'm not going to go into the details, but this math.round is a built-in function in JavaScript. And in JavaScript, X can be anything. X's type can be a string, Boolean, number, or object. And in this code, this toNumber function tries to convert this X to a number. If it's success, then it's going to be a number. Otherwise, throw an exception. So after this number 2, that should be a number. And we should use n. But from number 3, the editor used X, which signals a type error. It was actually happened in an internal version of ECMAScript. So this is a kind of a bug in the specification. And in ES Meta, we have several tools, but briefly speaking, we can type check the specification and we can test the specification. So JSTAR is a tool to analyze the JavaScript specification. Because it's a program, we have concrete semantics of that. When we have a concrete semantics, we can have an abstract semantics of that. It's kind of an abstract interpretation of the specification, specialized to type information. So that's our tool, and we found many errors in the specifications and implementations. And jest, it's to generate test data, again, out of the specification. And I'm skipping the details because they are papers and you can read them later. And this, using jest, we could find 27 bugs in the specification and 44 bugs in engines. So maybe that's only for JavaScript? Not really. Even though WASM was really well written and all those checking and standardization process, we still have bugs in WASM specifications and more in the proposals, right? And these are the bugs that we could find by using SpecTech. There are type errors like missing recorded fields in formal rules, semantic errors or prose errors. We are familiar with missing some names, right? Defining names before using it, and lots of editorial errors. So by having this kind of mechanized language specification, we can not only test the specifications, but also make really cool tests that are easily being missed by manually writing tests. So for example, this is a bug that we found in JavaScript core. Even though the WASM proposal, each of them is really well tested individually, right? But in WASM 3.0, we have several proposals. So this is an example that JavaScript core has a bug when it appears only when both garbage collection proposal and the SIMD proposal are used at the same time. Okay. Another thing is that the WASM has three kinds of specifications: the core specification and JS API and JS Web API, like that. And the core specification is really well checked and tested, but maybe not JS API. And whenever I meet those people, they were like, oh yeah, look at those problems. There are many bugs. And oh yeah, and this is one bug that we found in V8 that happen only when this WASM code is called by a JavaScript function. So there is these interactions. And finally, different implementations, like different engines or different browsers, implement different sets of the specification. Why? Yeah, I couldn't understand that in the beginning, but now I'm understanding. The WASM 2.0 is the official version, and WASM 3.0 is soon to be the official version. In between, there are many proposals. And these JavaScript developers and WASM developers are really diligent. And they'd like to use them even before those features are standardized in the specification. then browser implementers are really diligent to implement them before they are standardized in the specification. So yeah, these are examples. Maybe I will show you later. But so we found errors in various browsers, and it might be difficult to find them. So in WASM, there was a proposal called profiles, meaning that even though WASM is really big, maybe we want to support only a subset of it, depending on the applications. So that's profile. It has pros and cons, obvious pros and cons. It may fragment the language, and there are going to be some discrepancies between implementations. So it has been discussing for like 3 years. But if the community group wants to take this, then SpecTech will be really helpful in a sense that instead of making one each test set for each implementation, we can just change the specification and generate the tests targeted for those implementations. Okay, so specs are not oracles, and JavaScript ES-Meta statically analyzes the specification and generates tests. WASM does more than those things. And I believe that now that those languages with rigor specifications have these many bugs, then we can find more bugs in languages without specifications. So that's our belief. And now the third, we have to work with the language community. At ECMAScript, we were happy and we were lucky to have these awesome editors. One of them is sitting here, and we contacted them, and they were kindly invited us to give presentation. So we made a presentation, and you can read the actual discussion there. And yeah, someone said, this is the maximum that I've heard in terms of positive feedback for a presentation. And even on top of that, can we just move these tools to stage 4? Meaning that in this standardization process, there's a stage 0 to stage 4, and then approve. They are asking to just take it. So that was a big success. And I really wanted to emphasize that this was possible thanks to the prior work, right? This is our picture about citation, about JavaScript analysis work. And these two little boxes are the very first type system papers by Sophia and Peter Tiemann. On top of that, there are so many papers, right? And on that, I wrote some names. Lambda.js by Arjun and Shriram, K.js by Taejun and Grigor, the K framework, and Thais from Anders Miller, JSI from Ben Hadekov, Walla from IBM TJ Watson, JSOL and JCert by Philippa and Ellen, and Safe by our team. There are all these people working on JavaScript analysis. That's how we can convince the community, I think. And 5 years before we made a presentation, Philippa made a presentation at the TC39. They were exposed by this peer research. And yesterday I learned that before Philippa, Arjun and Shriram gave a presentation at the TC39. So thanks to this prior work, we were lucky to have this opportunity. And WASM also, the WASM standard, there's only one editor, Andreas. And it's not only that we need to convince Andreas, but there's the community. So after meeting the people in March at Docs2, in October, we gave a presentation in front of this WASM community group. And thanks to their work, we could make the adoption. Yesterday, here, we had this workshop, RPLS. It was really well received. The room was packed and people were standing back all the time. And this was the last session with a panel. And Ralph about Rust, and Xiao Hong about the K framework, and Jonathan about P4, and Michael about ECMAScript. There are many cool things, and I strongly recommend you to watch our video later. And the quote that I got from Michael is, ES-Meta doesn't cover everything. It doesn't cover modules, it doesn't cover atomics, but it's okay. It doesn't have to cover everything to be useful. 96% is much better than 0%. Right? And we don't need to report bugs because the people in Korea University already know by using ES-Meta. So efficient, right? Another thing that I wanted to steal from Michael is we need to share the same vocabulary. We are working on JavaScript. We are working on what wasn't, but in academia. In a relatively safe place, I guess. And when industry is thinking about adopting some technology from academia, they feel a bit risky because we know, when students graduate, who's going to maintain the tool, right? So these things. So when we deliver ES Meta to TC39, the first thing they asked us is like, can you rewrite your implementation in JavaScript? What? That's written in Scala. So we were like, we'd like to be good people. So we tried the TypeScript for 2 weeks and forget about it. and then now Jihyuk's group is maintaining that. So we have to work with the language community. JavaScript, they have this TC39 and the rigorous TC39 process for making changes to the specification. WASM, it has this W3C process to describe how feature proposals progress through the standardization process. For the other languages, we are looking at them. The governance even is not clear. Whom do we need to talk to, right? And the final lesson is, it takes a lot of commitment. Look at that. Our first GSTEC paper was published in 2020, JEST 2021, JSTAR 2021, and we were so happy. We contacted the editors, and we had the first meeting in November 2021. They were also excited. They invited us to the plenary meeting in January 22, and they were excited again. You saw that, right? And it took 10 months to make the integration, thanks to Jihyuk and my prior students. And after that, we had another JSaver and JEST paper, and last year we have KECUN paper. Here, this picture does not include everyone, but a gang of students had to work on this. And SpecTech, it's a bit different. We met the people at Doctoral in March 2023. We had the first presentation in October 23, and our first paper was last year's PLDI. And then the committee was really fast. Last June, they had this conditional acceptance, and this March, they officially accepted the tool, and now we are integrating it. So this is like a whole lot of commitment. But it opens the door to new opportunities. This is our PLDI'25 paper. I really like that because when we generate test data, we talk about those testing criteria and coverage metrics that we learned for longer than 50 or 70 years from this SE community. But this is a new kind of program. The spec data is not really a usual program. It has very specific characteristics that we can explore how to test them better. And this one was also I learned yesterday. Jihyuk's group is going to have a presentation next week at FSE. This awesome tool. This is a very proud moment of ex-advisor, right? So take a look at them. It's really cool. That's all thanks to the mechanized language specification. And finally, our group has been finding lots of errors in WASM implementations. And sadly, I cannot share the details because it's under review, but I hope to talk about them more later. So we have many FAQs, like, can I use SpecTech for my favorite language like Go and Scala, OCaml, Rust, those questions. Is SpecTech DSL readable, usable for developers? Really? Do you really think that the DSL is good for developers? Can we use English as the single source of truth? Those inference rules are too heavy for me. Can I use just English phrase? I just say something and the tool magically makes some code? Can you mechanize 5G, 6G specifications? It's for real. And this is from my colleague at KAIST in the electrical engineering department. From the very beginning of our GSTEC paper, he came to us like, can you please make this 5G specification mechanized? And he visited us again this year to give a presentation to ask for that. So there are many things. To support a new programming language, we have many things to address. And I'm not going to go over into one by one, but it's still ongoing research and we are learning along the way. So to sum up, we believe that specification mechanization is an enabling technology to automatically generate tools for language semantics and to help us to explore new possibilities. And our work on ES Meta is now mainly taken by Professor Ji-Hyuk Park at Korea University. Our work on WASM SpecTech is now split into this spec integration led by Andreas, and mechanized formalization by many colleagues, and lightweight formal methods by our group. And our group is also working on some other programming languages, and hopefully we can talk about that later. And now, finally, the second part. Yes, what PL can do for social good. Yeah. This picture was taken 10 years ago, in 2015 at PLDI with me and my ex-Sun Labs colleagues. I worked in sub-microsystems from 2005 to 2009. And I got my degrees, bachelor's, master's, and PhD all in KAIST. But I didn't know that back then. I didn't know that Sun donated Sun Spark stations 5, I guess. I'm not sure, but 5 stations to KAIST. And there were some students who were so grateful, so they made a club and named Spark. That's the club. And this person is my college friend. He was one of those founders of the Sparks Club. And now he's a rich person. He's running a company called Crafton. And now Crafton is the silver sponsor for this PLDI 2024. And he keeps talking about how he is grateful for KAIST and the Sparks Club and some microsystems for him to be in his current stage. And this was one of the main motivations that when Talia made this SIGPLAN M program and asked me to be on part of this advisory board, I felt like, oh, this is my turn to return what I've received when I was a student. And now we can share what we've learned and what we've received to those purple map, right? So I was happily involved, and I'm still on advisory board and a mentor. We even wrote a CACM article about this, long-term mentoring for computer science researchers, with a similar group in the computer architecture community. And I was also recruited by Catherine and David about this SIGPLAN CARES. I didn't really know about this committee, and when they recruited me, I had to study, and I was like really impressed by their passion. I learned a lot from these committee members, and I was also nicely surprised that there are many CARES committees in other SIGs. It was very impressive. So all these education helped me to make some movement in KAIST and in Korea. In Korea, we do not have an anti-discrimination law. So it has been a long battle with the government and people who are against it. Why? I don't know. And KAIST is not an exception. So 2017, we established KAIST Social Inclusion Committee, and I was the founder of that committee. And in 2022, we made KAIST Declaration for Diversity and Inclusion and made this video publicly available and got malicious comments. Right? And one of our main representative activities is to make restaurants for all on campus. We got civil complaints. We are still getting them. But thanks to our brave actions, other universities are following, and other universities are making these restaurants for all. This is just one instance, and we are trying to make differences. And personally for me, that's all educated by this community. And I'm recently helping Kakao Impact. Is a non-profit organization. This organization is to connect technology and platforms for solving social issues. We are running courses at KAIST, and this course is now being opened in other universities. And we are trying to help computer science students to be exposed to social issues and learn that we can solve real-world social problems by using our technology. So I admit that I'm using the term PL too broadly here, but I'm so grateful that this ACM's core values include diversity, equity, and inclusion, which makes me feel really proud to be a member of this community. So this is our journey to make this world a bit better place using our technology. And I'd like to share my sincere gratitude to many people I owe to, especially my beloved students. Thank you for listening.
Thank you so much for the fantastic keynote. We've got a few minutes before break for questions. So anybody who is curious about anything in the talk, please step up. We've got a couple of mics running, so introduce yourself and ask things. Maybe to kick things off, one thing I was curious about, you talked about growing a language, and a lot of times we think about that in terms of adding features, but also sometimes we deprecate and remove things. So are there any aspects in these projects that have come up that have been challenges with deprecation or removal, or is that something you're looking at moving forward? Or?
Right. The first paper, I think, instead of the introduction of our framework, the first paper we did was to how to safely remove the with clause in the JavaScript language. The with statement is the only dynamic scoping language construct in JavaScript, so we wanted to remove it. So by having this mechanization, we can have lots of combination of testing, and we may be able to show that this feature is not really necessary or prove its duplicative feature.
Super cool. Please.
Okay, hi, I'm Longfei Qiu from Yale University. Very exciting work. I'm curious, so when you started the ES Meta project, I think you said that a lot of the parts of the specification is already quite suitable for formalization. So are there aspects of the specification where it seems to be well defined on paper, but it turns out to be very difficult to formalize? For example, in C language and C++, they have lots of places where they say it's undefined behavior, but then there are corner cases where it's difficult to tell if it's triggering the defined behavior or not. Mm-hmm. There are such challenges in building the ES Meta project.
Mm-hmm. Thank you for the good question. So the second part, about this undefinedness, even ECMAScript has this implementation dependent or host environment dependent things. But it's good if we have explicit places to name them. Then we can abstract that away and do some other techniques. So that's one thing. Another is that was it 2015? Some year before and after, the style of writing the semantics was changed in ECMAScript. Before, it was not really clear about continuation, but now it uses first-class continuation, and you need to rewrite the specification. If you formalize it manually, maybe a year or almost a year, but by describing this semantics nicely, we can do that if we take a kind of DSL first approach. But again, think about this. ECMAScript, the language in the specification is the oracle. Sometimes wrong oracle, but it's the oracle. We need to follow that. So it has different kind of problems and issues.
I see. Thank you very much.
I'm
Hey.
Ali Donaldson from Imperial College London. Thanks for the wonderful talk. You mentioned that between WASM 2 and WASM 3, there were lots of different extensions and new features being experimented with by browser makers. So I guess I wondered if you could say a bit more about the interplay between being informal and exploratory and implementing things before specifying them versus specifying things upfront and implementing them later. Is it a mixture of these things that's going on, or is it that things kind of settle down in implementations and then get formalized after the event?
So thanks for the good question. The WASM community group, they have this culture that they need to describe the semantics formally first, thanks to Andreas. So either in prose and then formal rules, whatever. But if there are developers in the browser companies and they implement them. So altogether, they are just that happen all the time, and they have long discussions. Like in order for a feature to be standardized, it often takes several years. So I think that's the current status. And now that we have SpecTech, people are excited that that timeline is going to be shorter. And but still, which one is the first? It depends on the writers. It depends on who writes that proposal. If the proposal is from Google, then highly likely from the implementation. If the proposal is from academia, highly likely from the formal rules. So that's it. So they have different tastes.
Great, thank you.
Hey, Adam Chapala from MIT. So you told us about several long campaigns to get particular specification techniques adopted for particular languages. And some other things in the world are changing at the same time, like the importance of highly parallel execution. The two languages you focused on seem pretty inherently sequential in the notations that they adopt and the kind of data flow patterns that show up. If we look forward to languages where it's really important to support thousands of parallel threads, what would you see being different in the kinds of tools and even maybe social approaches that you're pushing here?
Yeah, thanks. The main thing I think I'm trying to deliver with this keynote talk, because I talk too much, the main thing is we need to have the formal semantics first, period. Actually, I'm stealing this title from Xiao Hong's talk yesterday. So if you have the formal semantics in K-frame, in K-style, or in big step semantics or small step semantics, I'm happy if you have one. And for concurrency and non-deterministic semantics, we've not yet touched it. So we are far from there. But we made a baby step to deliver our research to the industry. And now that we are aware of that problem, people are asking about those things. So like, how are you going to test non-deterministic behaviors? How do you do that at LLVM? And those many questions. So we are along the way, but far from there. Thanks.
Thank you.
I'm going to exploit my privilege to actually ask another one. So maybe another way getting partially at some of the things from Adam's question. You emphasized that a key design decision was to focus on a particular language and not make the tools overly general. So I guess moving forward, like how do you think about frameworks for language specification like MLIR or things like that? Is that a mistake? Should things really be much more narrow? I don't know.
So a very good question. So yesterday with our workshop, Peter Tso, he had to give a talk remotely. He had tons of questions like that. Like, who's your audience? Academia, industry, entry-level students? What is your application? Like, or what language do you want to write? In your research paper or real-world application, product line language, everything is different. And when we have this, like, we have WASM-specific and JavaScript-specific thingy, then people ask, like, that's like one for each language. What is there any lesson? Yeah, there is a lesson that we, again, believe in the benefits of formal semantics and the methodology that I discussed. And what we view this problem is, it's like a programming language. There are so many programming languages. So maybe we want to pick one ADA to do everything. Really? C and Rust are good for good performance. And OCaml and Haskell are good for functional programming. And JavaScript is really good for what is doing well, right? So every language is different. We think our approach, like Sail is really good for ISA instruction semantics, and K is good for if you want to check the concrete semantics really quickly. So they have different purposes. So we are more into actually helping or using in the real world industry problems. So they have different problems and different ways to solve them.
Fantastic. Oh, yeah, please.
Thank you for the great talk. And I have two questions. And the first one is to raise the fund for this mechanized language specification. How you tell government or company the effect of this work? It's not about directly earning money.
Very interesting question. Yes, thank you. We never asked for money, but so we are helping people, developers to lessen their difficulties in writing software. We are also helping people to use more safe and good software. So in that sense, we are well funded by the government in Korea. So we didn't think about it that much. Yeah.
And the second question is about this work can be extended to general software development. And it reminds me that some behavior-driven development or kind of work, but actually it is not quite popular well today. So what is the difference and how it can be adopted to general software development?
So I just tell Zach that this is not for every programming language, so that's even bigger. Just to rephrase the question, I think that again we can emphasize the benefit and the beauty and the power of formalism. And if you want to develop some software, you'd better know what you are doing. You'd better know what your software should do. Then describe the behavior formally. Then your implementation is going to be highly likely correct. Thank you.
Hi, Andrew Myers from Cornell. Great talk, really enjoyed it. So your approach seems really effective, but I'm wondering about the notion of ground truth here. So you have your own DSL. This is sort of a follow-up to Zach's question, right? So you have your own DSL, and then you have a bunch of tools that are translating that into other things. So is the ground truth of the meaning of your specification now embedded in the code that does the translation into, say, Rock?
Right, very good question. The trusting core is, what is that? So we are actually working on meta theory of spec tech. That's one thing. And another thing is like we are testing our specification as well. Meaning that we describe that in the spec tech DSL, and out of that we generate an interpreter. That's just the same thing. We have multiple implementations by Google and other companies, and we use differential testing to test the behavior. So we cannot prove it yet, and I hope Philippa and Conrad and other colleagues can prove that, but that's our current status.
Thanks.
Okay, I think that we will go ahead. Thanks Sukyoung again for a fantastic talk.